Hi, let us see the time response of a second order system today. A second order system can be written as Wn square by s square plus 2 chi omega n plus omega n square, where n is known as the natural frequency and chi is a uh, damping factor. Uh, now, the step response of the second order system is pretty sensitive to the value of chi. So to start with, let's assume that chi is greater than 1. So if chi is greater than 1, the denominator or the characteristics equation of this transfer function will have two real root. That means if we solve a square plus omega n square is equal to 0, we'll have is both a real number. Okay. Now let us see the step response for this transfer function. So Qs is equal to 1 by s. Ys can be written as so this expression can be rewritten as okay. Now the time response is obtained by taking the inverse Laplace transform, which can be written as so 1 by s is nothing but 1, and then s by 1 by s plus w1 is e to the power w1t. The second term can be written as just by solving a simple equation we can derive a and b, and both w1 and w2 are. Let us assume the value of chi is greater than 0 but less than 1. Then output is which can be written as 1 by s minus so if we just break it again, I will rewrite the denominator as well. This one part. The second part is okay. So we can rewrite this information again by s plus chi omega. Okay, so now if we take the inverse Laplace transform, I will be using this the following form of Laplace transform. So if s plus a by s plus a square plus b square is the transfer function expression in s domain. The time domain equivalent is cos bt, and if the s domain transfer function is s plus a square plus b square, then this is equivalent of sine bt. So now I will take the Laplace inverse Laplace transform of y. So the first term we already know this is 1. Oh, the second term is minus chi. Okay, we have e to the power at will be the minus at is missing. So e to the power minus chi omega n t cos omega n root over 1 minus chi square into t. Okay, and the second term will be same as okay. So this can be rewritten as a so let us assume for the time being wn root over 1 minus chi square is equal to wt, and root over 1 minus chi square is equal to sine phi, and chi is cos phi, because this always satisfies sine square by cos square is equal to 1. So we are assuming that this uh, form right now. So we'll rewrite it like this: 1 minus to the power minus chi omega t by root over 1 minus chi square into uh, sin phi cos omega dt plus cos phi omega dt. Okay, so this can be written as 1 minus square sine omega dt plus phi. Okay, so this is the expression for a step response for the second order system when xi is between 0 to 1. Now if I look into the mathematical expression, the first component, this is the exponential component, and this is a sinusoidal component. So sinusoidal component keeps dying and exponential component is dying with time because it's minus t. So it's dying with time. So there will be initial sinusoidal oscillations in the time response, and then essentially that will be dying out. And I'll try to draw it now here. So for the given expression, the output starts from 0 and it settles down after few oscillations. Okay, and this dying oscillation that is described by this exponential graph, which is this part omega giant t. Okay, now for this particular graph, or this particular graph is characterized by few more parameters. So one parameter is when the output reaches to 100% of it starting from 0. So this crossing point is known as the rise time, denoted by TR. The second point is when the first peak happens. So this is called TP. Okay, and how much it overshoots, what is the maximum overshoot beyond its final value. So this is the final value, and so what is this height? Okay, and then the fourth parameter is, so this is TR is rise time, TP is peak time, and this is MP. This is the maximum overshoot. Okay, and then when the output settles or enters the 2% or 5% band. So if the settling time is defined for a 2% band, then you can see that first time it is reaching this band is this time. So this is settling time. So let us try to derive the expression for rise time. If I start with the output in time domain, t, and that by definition the time domain output is 1. So this becomes 1 at t is equal to tr. So I will just replace them. Okay, e to the power minus j omega n tr. This is also tr. Okay, so that means tr plus is equal to 0, which means is equal to minus 1 minus square phi or tan inverse. This can be simplified as okay. So tr, let us derive the settling time response. So settling time of this time response is uh, dictated by the exponential component only. So we can just write that envelope in this form, and this value will come to 0.98 of the final value for 98 for 2% settling band. That means which in turn uh, okay. So settling is log 0 0.02 root over 1 minus chi square divided by now we will derive the peak time. So we'll again start with the time domain expression of the output. Okay. So now if we take the time derivative of the output, it can be written as uh, e to the power minus chi omega nt sin omega t minus okay, uh, and at t is equal to tp, the slope will be 0. So y time derivative of y will also be 0. So that turns down to the equation like this: omega n chi sin omega t plus phi minus omega t equal to 0. Okay, so now this omega d can be written as g square. So again, that means, and we have assumed earlier the chi is nothing but cos phi. So cos phi omega t plus phi minus this is sin phi is equal to 0. Means sin omega t plus phi minus phi is equal to 0, which turns t is equal to 0. That means the peaks will happen for wt into tp is equal to 0, pi to pi. And so if we see the time response, the positive peaks appears at pi, 3 pi, 5 pi and so on, and the undershoot happens at 2 pi, all these things. So first peak position is given by equal to pi by wt, which is pi by wn root over 1 minus that square. Okay, the last parameter in this time response is the maximum overshoot. So again, I'll start with the time domain output. Now at t is equal to tp, we have already seen that sinusoidal component is 0, and at the overshoot case, cos omega d tp will be minus 1. The output becomes, the peak output becomes 1 plus minus chi omega n tp. Now the percentage overshoot is defined as yp minus 1 into 100 for a unit step. If step height is different, then it will be yp minus step height divided by step height, and this gets simplified to e to the power minus chi omega n tp. Now tp, already we have seen that the first overshoot happens at tp is equal to pi by omega n over 1 minus chi square. If I replace that, 100 cross e to the power minus chi omega n into pi over omega n 1 minus chi square. Cross it simplifies to 100 cross to the power minus pi chi over 1 minus chi square. So here is the summary of all parameters. The time response is a complex dying oscillations, and it's a function of xi. And for the value of xi between 0 to 1, rise time, settling time, peak time, and overshoot are given with this table. That's all for today.